Hello, welcome back to my channel. Today we are going to solve Leetcode problem 79, word search. So we are given a board. Inside the board, there will be letters like A, B, C, etc. So we are also given a word like A, B, C, C, E, D. So we are going to search inside the board to find if there's a root can combine to this word. For example, we search from the first character A, B, C, C, E, D, and then it's the same word. So like this kind of a search problem, normally we will use DFS to search. Yeah, if we find a root, so we're gonna return true. If we didn't find in all the conditions for each one of the board, so we're gonna return a false. Yeah. So how should we solve it? Let's say the word less is like 15. So the m and n is less than or equal to 6. So it means the time complexity, for example, for the first one, when we go to A, we can go to two places. If we go to B, we can go to two places. Yeah, if we go to C, it means 3 to the power of 15 is our result for the time complexity. So 3 to the power of 15 equals to like 2 to the power of 25. Yeah, I just guessed the number. It may be like that. Yeah, so it seems it can pass for this. For this question for the time complexity. Yeah. Now let's just define our DFS search to solve the problem. Yeah. So normally for me, I will define a row and column. Yeah, so this is like my template. I will be using the board. Yeah, so the length of the board will be the rows, and the length of board 0 will be the columns. Yeah, and I'm also going to define a visited set. So here is my visited set because I'm going to use the DFS. Normally, I don't want to check the duplicate. So this is my visited set. And then I'm going to define a DFS function. So the DFS function is a search. Normally, it will search like row and column. And here inside, I will define I. So this I means the index of the word because I'm going to search the word, for example, this word. Yeah. So I'm not going to write the DFS first, but I'm going to write my main loop. So for the main loop, I'm going to check. So for R in range R, and for column in range, yeah. So for column in range C, I'm going to check if the board RC, it means the word. If I find a letter, it means if I find a letter, for example, this letter is A, equals to the word. So the word will start from which one? If the board RC equals to my word, so yeah, equals to this word 0. So it's the beginning, yeah, of the word. And DFS RC with I, so it will start it from 0. Yeah, if we find that, we're gonna return a true. Otherwise, we're gonna return a false. So this is the main loop. Yeah, so this means we're gonna start from the board position by position. We're gonna find the first letter of the word. For example, this word 0 means A. Yeah, if this letter from the beginning is A equal to this word A, so we're gonna check the DFS. Otherwise, we will not check it. For example, this is B. and the first letter of the word is A, we're gonna not check. So only we check this area and this area. This is for saving the time. Yeah, this is like a kind of branching or pruning for the DFS tree. Yeah, if we didn't find, we're gonna return a false. So here is inside, it is the DFS search. So about the conditions is if this I equals to n, it means I goes to the end of the word. So n, I'm going to define n as the length of the word. So if the length of the word equals to this I, it means I goes to the end of the word, goes to this place. This means we've already found the word, so we're gonna return a true. Yes, we're gonna return a true. Otherwise, we're gonna search for the next step. We might from A goes to B and C or D, yeah, etc. If we didn't find it, we will go backtracking, and then find again. Yeah. Now we will check our conditions. So we're gonna check if this R is less than, more than and equal than 0, and less than R. Similarly, for the column, it is more than and equal to 0 and less than the capital C column, and RC, this tuple, it means this point not in visited set. Yeah, it means this is not in visited, and we should also check board. This board RC, this point equals to this word I. So from the beginnings, I equals to 0, it's the first letter. Yeah, and here it is also equal. Yeah, so why we need this? Because we're gonna check one by one. From the beginning here, it's already checked, but it doesn't matter. For the next loop, when it goes to B, we're still gonna check. If this I equals to 1, index 1, we're gonna check B. If I equals to index 2, we're gonna check C. So this is also synchronized with the backtracking of the board. So the board RC should equal to this. Yeah. If meet all those conditions, so we're gonna put the point with a tuple RC into our visited set. So visited dot add the tuple, this point R and C, and I'm going to prepare the DFS inside a result, a variable, because there will be there will be some DFS. Yeah, there will be basically 4 directions, because for example, when I'm going to C, top, down, bottom, right and left. Yeah, left, right, top and bottom. I cannot go back, but there will be 3 directions, or sometimes it will go top. Yeah, because for me, I will go 4 directions. Only if I go from here, I cannot go back. Yeah, but for each time, I will check 4 directions. This is why I will, store the result, those values into a result. So for the DFS, we can use R plus 1 and C, and here I should plus 1 because the index should be updated. And similarly, DFS R minus 1. Yeah, because we are going to have 4 directions, and C and I plus 1. Yeah, here for Python, I think I can use backslash, and then DFS R C plus 1 and I plus 1. I plus 1 means the next index. Yeah, so C and R means 4 directions. Yeah, and all DFS R C minus 1 with I plus 1. Yeah, so this is the result. After that, I'm going to remove it. So visited dot remove. Why I need to remove? Because I'm I have to go backtracking. If I didn't find, I have to go backtracking to go another. For example, if I go to C, I go to S, I didn't find it's not equal, I go back and then go to E and go to D. So I needed to remove the tuple with R and C. After that, I'm going to return the result. Yeah, if the result I didn't find, yeah, I'm gonna return a false. So this means even I didn't return false, if I didn't find the result, didn't return true, it means the final result will be none, and none will be a false. Yeah, I think this is basically the entire code. Now let me check it if I make any mistakes, because for such kind of code, it's very easy to make mistakes. So this is the conditions for me to check. And here I put it inside. Here is the result, and remove and returns. Yeah, now let me run it to check if there are any mistakes. Yeah, syntax. So what is the syntax? I cannot use. I cannot use this syntax. It is this way. /. Let me check. Yeah, I did something wrong. Now let me check this syntax. This is DFS RC R-1 CI +1. Or I didn't use or, I believe I didn't use or. Now let me run it. It should be / for 2-line in Python. Yeah, now it seems okay. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, and it's not so fast, but it's 80% of all submissions. It is like 5 seconds or 6 seconds. But how can we improve it? Yeah, so there's a trick to compare. I mean, to stop the DFS earlier. Actually, if we find that trick, we don't need to go the DFS. We should return the false directly. Otherwise, we go DFS. So how to find it? If we combine all these letters, like this A, B, C, E, S, F, C, and S, combine all these letters, and then compare with the word. If any letter, like for example, this A is less than the count, so the count of A may be here. For example, this A is yeah, this is 2, but I will make it 0. For example, inside the board, the letter A is 0, but inside the word, the letter A is 1. So we're gonna return false immediately because there's no letter A inside the board. We're gonna return it. Similarly, we can check each one of them. Yeah, so we can use a trick to let the DFS tree. Yeah, we can check it earlier. If we find a false, if we return false, we don't need to go the DFS. So how should we do that? I'm going to define a board string. So the board string means I'm going to turn these letters into a string and then compare it with the word, because I can use a count in Python to count its letters. Yeah. So I'm going to use a joy. So empty string dot joy something inside. Yeah. So inside I'm going to joy like these characters. So how should I joy? So inside I'm still going to use a joy empty string joy this item. This item is like A, B, C, E for each of the rows. Yeah. For I in the board. Yeah. Now let me print the board string to check what it is. Yeah. So the board string is combine all these single letters inside the board. So this is the board string. We'll combine it together, and then we are going to check if any baud string baud string dot count a character. If any, this I will put it inside a string. Inside an empty string. If this count is less than word dot count character for character in word. So I'm going to check this word. If any character in word, the count inside the board is less than the word count, it means definitely it will be false. Otherwise, we are going to use DFS to search it. Now let me run it to check if there are any mistakes. It seems okay. Now let me submit it to check if it is faster than before. As you can see, it is now less than 1 second, and it's nearly 96% of all submissions. It's pretty fast for this kind of tricks. This is also a pre-pruning. It means before DFS, we can still pruning. And inside DFS, we used this kind of method. It's also a kind of a pruning. We check the first letter and then use DFS. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this.